Here is a small table of 7 students, a roll number, a name, a department, an age, and their marks. Everything we do today lives on this one table. So take a good look at it. Now someone hands you this. Select name and marks from students where marks is at least 60. And they ask, before you touch a keyboard, which rows come back? To answer, you have to run this query in your head, like a tiny data pipeline. By the end of this lesson, you will trace any such query, filtering, joining, grouping, and know its result exactly. Let's build that skill, one clause at a time. Here is the whole spirit of SQL. It is a declarative language. You describe what you want, the shape of the answer, and the database figures out how to fetch it. You never write loops over rows yourself. And if you have met relational algebra, SQL is just its friendly face. Selection, sigma, which keeps the rows that satisfy a condition, becomes the where clause. Projection, pi, which keeps only the columns you name, becomes the list right after select. And a join, the bow tie, which stitches two tables together on a matching value, becomes the join keyword. Same three ideas, now written in words you can read aloud. Let's trace it properly. 3 clauses, and they do not run in the order you read them. From comes first. It names the table we start from. All 7 student rows land on the table. Next, where. It looks at each row on its own and keeps only those with marks at least 60. Watch the failures fade. Rohan has 45 gone. Kiran 55 gone. Lata 30 gone. 4 rows survive. Finally select runs. And notice it runs last, not first. It keeps just the 2 columns we asked for, name and marks, and drops the rest. The result is exactly these 4 rows. Asha 80, मैं 70, Dev 60, Imran 90. A few small tools reshape the answer. Distinct removes duplicate rows. The depth column has 7 values, but with lots of repeats. 3 CS, 2 EE, 2 ME. Distinct collapses them. Only 1 CS, 1 EE, 1 ME remain. 3 rows, not 7. 3 more. As renames a column in the output, name becomes student, purely a label. Order by sorts the rows. DEC means highest first, so marks run 90, 80, and so on. And limit keeps only the first few. Here, the top 2. So this query returns the 2 highest scorers, renamed nicely. Imran 90, then Asha 80. Remember one thing? Order by only rearranges rows. It never adds or removes them. Limit is what trims the count. Real data lives in many tables. Students keeps names and department codes. A separate depth table keeps each code's building. A join stitches them together on the shared column, where the student's depth equals the depth in the depth table. Take Asha in CS. The join looks up CS in the depth table, finds Turing, and glues them into one wider row. Asha, CS, Turing. It does that for every row that finds a match. The joined result carries columns from both tables side by side. This is an inner join. Only rows that match on both sides appear. One variation worth knowing. A left join keeps every row from the left table even when the right side has no match. Here the depth table has 4 buildings, but the CE department, IFL, has no students at all, so its row still appears in the result. IFL is there, but the name is filled with null, skewness marker for a missing value. A plain inner join would have dropped that row entirely. That's the whole difference. Now the big one, grouping. Often you don't want individual rows, you want a summary per category. Group by depth says, gather the rows into buckets, 1 bucket per department. Picture each student as a chip carrying its depth and marks. Watch them sort themselves into 3 buckets. The CS bucket gathers Asha, Rohan and Dev. E gathers May and Lata. ME gathers Kiran and Imran. Every row now belongs to exactly one group. Then each bucket collapses to a single summary row. Count star tallies the rows. CS has 3, E2, ME2. And AVG marks averages each bucket. CS is 80, 45, 60. That sums to 185. Over 3 is 61.67. EE averages 50. ME averages 72.5. The aggregate family is small and worth memorizing. Count tallies rows, sum totals a column, average averages it, and min and max pull the smallest and largest. Each squeezes a whole group down to one number. Now the classic confusion, where versus having, where filters individual rows and it runs before grouping. Having filters whole groups and it runs after. Here we already have 3 groups with their counts. Having count star at least 3 keeps only groups with 3 or more rows. CS has 3. It stays. EE and ME have only 2. Both groups are discarded whole. The answer is a single row. CS 3. Hold the distinction firmly. Where talks about a row, its marks, its age. Having talks about a group, its count, its average. You cannot put count star in a where clause because when where runs, the groups don't exist yet. Sometimes a query needs an answer from another query. That inner query is a subquery. Here we want students older than the average age, but we don't know that average yet. So we compute it inside first. The inner query runs on its own and resolves to a single number. The 7 ages sum to 144 over 7, which is about 20.57. SQL substitutes that value straight into the where. Now the outer query is ordinary. Keep rows where age beats 20.57. Rohan at 21, Kiran 22, Lata 23. Those 3 come back. The subquery let one query lean on the result of another. This is the single most important idea in the whole lesson. The order you write a query is not the order it runs. You write select first at the top, but it runs in a completely different order. From builds the rows, where filters them, group by forms the buckets. Having filters those buckets. Only then does select choose the columns. And order by sorts, dead last. This explains 2 things at once. Why? Where can't see a column nickname you defined in select. Select hasn't run yet. And why filtering always happens before grouping. Learn this pipeline and every query becomes readable. Your turn. On the same 7 students, this query groups by det and counts each group. Pause the video. Work out exactly how many rows come back and the count in each. I'll wait. Here's the walkthrough. 3 distinct departments appear. So you get 3 rows, 1 per group. CS holds Asha Rohan, Dev, count 3. EE holds me and Lata, count 2. ME holds Kiran and Imran, count 2. Final answer, 3 rows. CS 3, EE 2, ME 2. If you counted the groups first, then the rows in each, you traced it perfectly. That is the whole method. Trap 1. The big one. Where is for rows, having is for groups. Never put count or average in a where. The groups don't exist yet when it runs. Trap 2. Select runs near the end. So a column nickname you create there cannot be used back in where. Where ran long before select. Trap 3. Count star counts every row, nulls included. But count of a column skips the nulls, and averages and sums ignore nulls too. That gap changes results. And trap 4. Every plain column in your select must appear in group by. And to test for missing values, write is null. Equals null never matches, because null is unknown, not a value. Let's lock it in. A query is a pipeline. From builds the starting rows, then where filters them one row at a time. No aggregates allowed. Group by gathers rows into buckets, and having filters those buckets by their aggregates. Count, average, and the rest. Select then shapes the output columns and runs late. So no aliases in where. and order by sorts at the very end, changing order but never the count. Join stitch tables together on a shared value, and subqueries let one query lean on another. Trace any query through from, where group by, having, select, order by, and you will always know exactly what comes back.